The ECM uses various signals from the crankshaft position sensor for detecting the engine RPM and the exact position of the piston, the camshaft position sensor for detecting and distinguishing the positions of the piston of number 1 cylinder and that of number 2 cylinder exactly, the accelerator position sensor 1 and 2 for detecting the driver's driving intention, the mass airflow sensor and the intake air temperature sensor for detecting the amount and temperature of the air inflowing into the engine, the fuel pressure sensor detecting the fuel pressure and sending it as the fuel pressure feedback signal, the coolant temperature sensor for detecting the coolant temperature, the boost pressure sensor for controlling the VGT, the wide-range oxygen sensor for detecting the oxygen density in the emission from the exhaust pipe and for controlling the AF ratio, the exhaust gas differential pressure sensor for measuring the amount of the PM gathered into the CPF and for sending its data to the ECM to regenerate the CPF, the exhaust temperature sensor 1 and 2 for maintaining the temperature in the CPF to 650 degrees Celsius at CPF reproducing, the brake switch for sensing the brake condition of the vehicle and for sensing the adhering condition of the accelerator, and the clutch switch for maintaining the variation of the engine RPM in stable according to the operation of the clutch. The signals from these sensors and switches are inputted into the ECM. The ECM, receiving the signals from the various sensors, conducts the fuel amount control for changing the fuel injection timing and amount at the injector, the fuel pressure control for controlling the pressure generated by common rail at the dual pressure control valve, the swirl control valve control for enhancing the output and reducing the emitted particles by varying the intake manifold path according to the engine load, the air control valve control for reducing the engine vibration at ignition off and the nitrogen oxide generated during driving and for regenerating the CPF properly, the VGT control for controlling the VGT exactly by changing the duty of the VGT solenoid valve, the EGR control for recycling the emission to reduce the nitrogen oxide generated during engine combustion, the cooling fan control for adjusting the fan speed in low or high speed when the engine is heated or the air conditioning is activated, the CPF control for maintaining the CPF temperature in high temperature using the post-injection, the fuel pump control for supplying the fuel to the fuel line when the ignition key on signal and the engine RPM signal are inputted into the ECM, the glow plug control for enhancing the ignition at cooled state, for maintaining the engine RPM state properly and for reducing the emission, and the PTC control for heating the room temperature under cold weather.